So hello everybody, today's video is about Python again. This is I think the 5th course, and this video is probably going to be longer than usual. That's because today we are gonna make an AI. By that I don't mean like an AI that can actually like make responses like ChatGPT, but I just mean an AI who you like tell stuff and tell it what to do when some user tells it that. And basically it's like a learning AI. So I'm gonna actually explain the core concept. There's gonna be a dictionary that's gonna contain the request and the response. When you like ask the AI something, if the request is not in its like dictionary, like its memory, we are gonna call the dictionary its memory. If it isn't in its memory, it's gonna ask you what to say when you ask it that. And basically that is adding a new key to the dictionary. The key is the request you asked, and the value is the response you give it to give when we are like telling it that thing. We are also gonna use the lower string.lower function to convert the responses and request into lowercase, so the case does not mean anything. Like you can type all in uppercase and it would still work. So let's get started. Basically we are going to use a module for this. Let's make a new module called ai.py, and in this module we are going to make a class called, guess what, AI. So first of all we are going to make an initialize function and add a dictionary which we'll call memory. And just so my VS Code completion is better, we are gonna just add this thing. If you are using PyCharm, you probably don't need to add this, but I'm using VS Code now, so I have to add it, otherwise the completion won't be good. So we are actually gonna have a simple set of responses for certain things, but then all the other things is the user teaches the other things, like hi. And actually we are also going to use the starts with function. So like if you put hi and then add an exclamation mark, the AI will still say hello. Hello, how can I help you? So we are going to do get response. This is the function get response, and we're gonna add a self argument obviously, and then an argument request will be string. And I'm also gonna teach a good practice here that I already probably told you about, which is that when something is not true, you do it at first and then return if it is not true, then do the second condition. Like we are first going to check if the memory doesn't have the request instead of checking if the memory does have the request. So if it doesn't, then we are just gonna like call the learn something function and then return nothing. Actually return an empty string, and I'm also gonna add this so my completion is better. This is basically specifying the return type. So we're gonna return an empty string, which means the function ends at that point, and all of the code after that will only execute if this condition is false. So we're gonna check if if not self dot memory dot has wait a second. Okay, so basically I'm too much into like C and C++ and I'm using a function, but in Python you actually use the in keyword to check if there is a key in the like dictionary. So we are gonna do if request dot lower. Actually I have an idea. We're gonna make a variable in case sensitive non-case sensitive request. is equal to request dot lower. Wait, this is just too long. We're just gonna call it safer request. Request, not required. If not safer request in self dot memory. If it isn't in our memory, then we basically just like call the learn something function with the request, actually the safer request, and return an empty string. Actually we can just return none, but if it does exist in its memory, then we are just gonna print the whatever it is, memory safer request. So let's make a learn something function which will take a request argument, and actually just to make it more friendly, I'm just gonna print I'm unsure what that means. Could you please tell me? And in the learn something function, we return a string. Wait, actually we don't return anything, we just add it to the memory. So in the learn something function, we just take we can take an input using the input function, just like this, like response is equal to input. Use the input function without anything, it will just add an input, but you can actually add a prompt like this, and you can take input. When you take input, this will show up and you can remove it, and we are actually going to convert this to lowercase, so it is in case sensitive. So finally we are going to add it to the memory request. Request is equal to response. So I guess that is the whole thing, and I forgot to add a self here, that's why it's still showing that. So now that should be everything. Let's import the AI in. Actually we are going to import the AI class from the AI file. If you don't know already, I'm sure you watched the previous video where I told you how to do this, and if you didn't, this basically means you import a specific thing from a module. You can also add a commas to import more things in the same line. So finally we are gonna make a AI variable which will just be an AI, and we are gonna go in a true loop. Make sure to add something to actually terminate this loop, and otherwise it will forever run until the end of time. So we're going to take an input response, not response, request, which will be just an input u, and we actually check if request is exit, and actually lower this. I'm just gonna remove this. So if request is exit, then we just break and do, and then it just exits here, which is the break statement, so we can actually get out of the loop. Else we just tell the AI to get the response request, and actually we're gonna put this in response and check if response. If response, you do this like a boolean, but in Python, even if it isn't a boolean and it is just none, then it will return false. So like you don't have to do is none, and make sure to not use is too much, because is used to like check if the memory addresses are the same, and instead you should use equal, but for none you can just use is. But because Python handles it automatically, we can just do if response. If response, then print response. And the reason I'm doing this is because in the function we can also return none, so we don't obviously want to print none, so that's why. Okay, so let's run this. I'm using code runner to run this, and the reason it did that is because I already ran it, so we'll have to run it again. So let's add, ask something like hi. Look, it had hi in its memory, so it printed the output. But we can also do hi, so it will print the same. We can use any case, but it will print the same thing. And let's ask it what you do. Actually, how are you? How are you? I'm unsure what that means. Could you please tell me? Actually, let's make this bigger. So we're gonna say I am fine. And let's ask it again. How are you? I am fine. How are you? So this time I add an exclamation because I wanna do I am fine. And yeah. So that was the AI done. Actually, this is somewhat close to actual AI. An actual AI also has a memory, but it doesn't just use the memory to print stuff. It actually combines patterns and responses, it just crams responses and whatever it's learned into a response. It makes a response out of all of the things it put, and then just gives the user the response. That's how ChatGPT works. It just stuffs some things, some responses patterns into one response, and then gives out the response. That's how it works with probably everything. And the newer models are basically just advanced versions of that, because ChatGPT can't, the ChatGPT 3.5 can't cram code that well, but it can cram responses. So now let's actually get to one thing that is really important in programming, which is asynchronous programming. As I said, this video is going to be long. Asynchronous programming basically means you run a bunch of tasks separately, actually at the same time. If I print two things with a print statement, they will execute one by one. But if I use asynchronous programming, both will execute at the same time. And sometimes it is actually capped at the CPU thread limit, but on Windows and I think on Linux too, you can just use tasks. It is really complex, but Python has a module that really simplifies it. So we're gonna use that to simulate loading two files, actually 4 files with 4 different sizes, and it would look like we are actually loading files. If you are from Arch Linux, you probably always see Pac-Man downloading a bunch of things at the same time and wonder how it's doing that. Yeah, well, it's asynchronously downloading all of them to make the install process faster, and apt doesn't do that. So let's get to it. We import async.io. In the name there's async, that's the short for asynchronous. So first of all, I'm gonna tell you some rules of this. First of all, every function that is defined with async def instead of normal def, like this, should be called with the await keyword, because that is a asynchronous function, and that if you don't do that, then it would probably interfere with the running process. And every function that is defined with async def returns I think a argument or something that async IO uses to run it asynchronously. And that's why in async IO, when you gather functions, you call them instead of just passing them like you do in tkinter. So let's make one function. Actually two, because in async IO you have to make a def main function or whatever to actually run something, because it should be async, and you can't just make your whole program async, otherwise it would just frick the whole thing up. So let's make a function called async def load file. We'll take the file name and then the file size. We're gonna calculate how much time will it take to install the file, load the file. So basically that is the size divided by 10,000, which means 1000 size, 1000 bytes will complete in 100 milliseconds. So calculated load time is equal to size divided by 2. And actually let's convert this to an integer, because if the size is something like 1254, then it would be a like floating point number, and that is not good because floating point numbers are long as hell. So first of all we will print, we don't have to use await on print, we will just print starting load process for file name, and we will just use await async IO dot sleep to sleep for 1 second to simulate it starting the process. Then we will actually load the file. Loading file name, and actually estimate will be the calculated load time seconds. Wait, also I actually messed up. That's because I was doing an asynchronous programming test just seconds before this video, and I was using int in them, but you don't have to actually use int. You can just do 10,000. Basically if you do 1000 divided by 1000, it's 1. So if you do 1000 divided by 10,000, it's 0.1. Now the floating point number will still be hella long, but still. Now we can do s, estimate calculated load time s, which will actually seconds. So we are gonna do async IO dot sleep again, but this time for the calculated load time. And finally we are gonna print file name loaded successfully. Took calculated load time seconds. And we are going to now make a async IO, not async IO, await, or not await either. I think I have to mention now async def main function, and here we are going to use await async IO dot gather. Basically the gather function takes all the coroutine arguments from all the functions. As I told you, all functions that defined with async IO return a coroutine argument value. So it's going to take all of those coroutine arguments and use them to run them separately. And that means we are gonna have to call them instead of just passing them to it. So we are gonna gather load file 1, which will be game.exe, the largest file, 140,000. This will make it 14 seconds. Then we are gonna load another file, game.dll, 40,000, and then we are gonna load another file, preferences.exe, which will be 74,000, and finally we are gonna load the last file, which will be preferences.dll, which will be 23,000, and finally we are gonna run it using async.io. Async.io.run main. Let's run it. And actually, just to make it look more clear, I'm gonna go to my user settings again and make code runner run it in like the output pane instead of the terminal pane. So let's run this. Look, it started like at the same time. First loaded, second loaded. The third file is also loaded now. And the fourth file is also loaded. And the reason I know these are running asynchronously is because obviously if they weren't, then it would be starting load process for game.exe, loading file game.exe, then file game.exe loaded successfully. But instead it is starting load process for all the files, then loading all the files, and then file this loaded, and they are running one by one. They look like they are running one by one because each has a different size, but if I put all of them at the same size, like 8,000, then they will all complete at the same time, just to prove that it is running asynchronously. What? Look, and look. Everything is asynchronous. This is actually really important when you want to like read files and stuff or load a lot of data in games and stuff, but don't want to make it like too slow. And you can actually have more functions, but the last thing is make sure to always use async for whatever function has await, and use await for whatever function is async. And I think that's it for today. Let's see. Yeah, that is it. Goodbye.